All right, folks, we are at the session start time. This is the alert session. I'm Eric Bellum, the alert production group lead. We're going to go a little bit out of order today because we have a remote speaker who has a conflict at the top of the hour. So we're going to sort of jump in a little bit, maybe out of order conceptually, by starting to talk about the prompt products database, which is will be a user accessible database with the contents of the alert catalogs in it. Jeremy McCormick will speak to that. I'm not going to flash up for screen share and annoyance reasons. I'm not going to flash up the usual reminders, but I think you will have seen we have a code of conduct and we expect everyone to abide by it. I can point you folks to the language if that's relevant. So Jeremy, why don't you go ahead and take it away?
Okay, great. Thanks, Eric. Thank you for accommodating me. Let's see. Yeah, so apologies if this is conceptually a little bit out of order, but I assume that in this audience, there's at least enough general knowledge to understand most of the contents here. But at the end, if there are questions, please let me know. So let's just start with some basic information and background. So the prompt products database is a complete catalog of the alert data. And it's replicated from the alert production database, which is like the storehouse of the alert generation that the data pipelines work from. And the records in the prompt products database have the same object and source IDs as the alerts. So if you find those in the alerts, you could look them up in this database. And of course, they're the same as the IDs in the APDB. So the plan is that this data will be made available in this catalog within 24 hours of its generation. I think that will roughly correlate with when the alert is generated. So I think that that's the goal. And then the catalog is planned to be searchable through TAP with ADQL or other RSP services. So to be clear, this database is not publicly accessible yet. So just a little background on this project. So some early design documents assumed that user science queries could operate on the APDB, which is a kind of transactional database used for the alert production. But for a number of technical reasons that I'm not going to go into, this turned out to be infeasible. I mean, I think basically it has to do with the Cassandra database technology and the fact that you need to kind of split your analytical work off from the transactional work of generating the alerts. So we did a performance comparison of database technologies in that tech note listed there. And we considered Postgres and a few other technologies. And we kind of discarded Postgres because of some operational and performance constraints that we discovered in the process of evaluating. So out of the available options to serve this data, we decided to pursue a database called Google BigQuery. And this is a highly performant, scalable, and reliable service offered on the Google Cloud. And one plus was that there was a prototype TAP service available, which included geospatial optimizations. And BigQuery itself has a built-in spatial query optimization through its GIS functions and types, which can be mapped to ADQL. So all of these were nice positives of the platform. So there's a reference there if you want to, which was an early experiment with BigQuery using astronomical data. Which also informed our decision. So what's the current status of this database? So we have a fully functional and stable data ingestion pipeline from the APDB to the PPDB. There's a replication service which exports from the APDB into BigQuery staging tables automatically, which runs on us like a timer and checks the APDB for new data every few minutes. And so new data is handled, and we do have the capability to handle record updates, like from reprocessing campaigns when certain fields are updated. So both of those are handled in the system. So there's a promotion process also that was implemented, which periodically publishes data which has been staged. And so the new data and the updates are combined with the current tables and published every 24 hours. And to access the data, we have a tap service and portal access through the RSP, but right now it's only available to Rubin staff. So just a little bit about the approach for making this data public. This is we've been calling it promotion. So there's a requirement from some of Rubin's design documents that this data be made available within 24 hours of the observation times. That would be roughly when the alert was generated. And so we've adopted this in the design of the PPDB. And so the data being made available to the public is going to take the form of like a data drop, meaning that under normal circumstances, all the previous night's data from the alerts will be made available to the public through the TAP interface. And when this occurs, when the data is moved from like the staging into the public data set, runs currently at noon Chilean time, but the scheduling is fully configurable and could be shifted around as we gain operational experience, either to be earlier or later, hopefully earlier. This process should be resilient to failures. If the promotion fails, the next time that the promotion runs, it will attempt to move the stage data that failed into the next published set. So we haven't had to deal with that too much, but hope the process itself at least seems stable. It seems to work well. So what is in the PPDB in terms of tables? So we have the standard differencing imaging analysis tables that I'm guessing a lot of you are already familiar with. So we have dia object, which are the derived properties for transient and variable objects. Now in the APDB and also in the PPDB, the raw data of these objects is versioned using both a ID field and a validity start, because in other words, every version of a dia object has its own row. But in the public view, we plan to basically filter this down to only the latest version, so people don't have to do that themselves in their querying, which could be awkward. So we also have the dia source table, which is measurements for sources detected in the difference images. And this links to the dia object via a dia object ID field. And then finally, of these tables, we have the dia force source table, which has force measurements in the visit and difference images at the coordinates of all the DIA objects. So these also link to the DIA object table via dia object ID. Then, and not in the system right now, and they're not being automatically loaded, we will have the solar system tables, SS object, SS source, and PC orbits, and perhaps a few more to be determined. So the current state of the data is kind of outlined here. Just in terms of like what BigQuery can handle, this is kind of a small amount of data, and it corresponds to basically the total number of alerts that have been emitted. So yeah, just a few notes about that. The system is currently not caught up for some technical reasons, but we have visit data up until approximately the end of last month. So that kind of gives you an overview of the data scale, at least so far, though in operations, I think these numbers are going to be much bigger. So the primary way that we will provide public access to the data is through the RSP, through a TAP service, similar to how we do for other catalogs on the Rubin Science platform. And we have some interfaces that make this very straightforward to do in Python with just a few lines of Python code. So there's an example there of just getting like a summary from the dia object table. And users will they can reference existing tutorial notebooks for like TAP usage, because there's a number of different notebooks in the DP1 and now the DP2 tutorials. And then we'll also plan to provide some PPDB specific notebooks for users. And then another way to access the data will be through the portal, through the standard RSP portal interface, which I assume many people here are familiar with. So like there you can see some of the data overlaid on the HIPS image right there. And on the right, you have a plot of the area and deck. And then, of course, there's the table data returned by the system. This was just a spatial search that returned a few rows. So what's the status on the public release? So that is being targeted for sometime between September and October of this year. And we're planning to include the tables I outlined on the other slide. So the DI object table, which will be fully accessible, meaning you can do freeform SQL queries on that through the tap service. The DS source and DF4 source tables, we plan to allow querying on those by their DIA object ID through a specialized service. And then, of course, the solar system tables. And then the services will be TAP, so that will be accessible through Python notebooks. And then we'll have the portal access, which should have spatial search capability and possibly time-based search as well. And then the light curve service to like basically look up DIA source and DIA4 source records by their DIA object association. So I think we'll use the typical support channels for this when we release it. External users will be able to get support and updates through the Rubin community forum. Rubin staff can use our Slack. We have a Slack channel there, which can be used for directly interacting with the developers and other users of the system. So that's all I had. Keep it relatively brief. Do we have any questions?
Oh boy, I see lots of hands. All right.
Thanks. So I have a question. Is there a way that the daily prompt product database updates could be made available to the brokers to basically do a bulk automatic download so they can maintain maybe science-specific enriched versions of those databases?
There is not currently a way to do that besides exporting data through the tab service, which does work. All of the rows have time columns on them of multiple time columns for things like we have the visit, we have validity intervals on the objects, etc. So
Jeremy, I'm sorry, can I interject?
yeah, can I just finish? So
Okay.
I have not really done any work on on like a daily updating service besides working through the tab service and working off of those time fields. So I believe it's planned. And Frosty, what were you gonna add there?
Yeah. So number one, I know some of you are currently doing this, but do not crawl tables through the tab service. It's actually extremely inefficient for you as well for us. There are a number of more efficient ways that we are planning to make available leading up to DIA1 for bulk download of various products, and that will be better for everybody. However, specifically in the case of PPDB, we are planning on doing daily dumps and making them available. So please don't start crawling. Thank you.
Okay.
Hi, this is a general question about the portal on the RSP. So we've been having issues like, like we were going around like the heap maps and we kind of wanted to share the link of like a specific place we've seen to other people, if that makes sense. And that doesn't seem to work well. Like there is some sort of reset of the portal. So you can't share exactly what you're seeing with somebody else. Does that make sense?
I think that maybe be another question for Frosty or one of the RSP team.
We're asking if Gregory. I hear your question. We need to find the right person to get to answer that for you. Was there another question over there?
Hi, Jeremy. Thanks for the update. I was curious. Well, I have a two-part question. Um, the first one being, are the tables optimized in such a way to reduce the amount of bytes read by a query? And then the second part is, what strategies are in place to teach the community how to write efficient queries?
To your first question, we've had a lot of discussions around how to optimize these tables, and there's a number of different strategies that we'll use in the initial data release. So the first strategy that's, I think, working well and is relatively mature, you might say, is spatial query optimization based on what's called clustering in BigQuery, which you don't need to know what that is, but essentially we take ADQL function calls and then we map them into BigQuery in a way that it is able to perform efficient lookups if you provide RA and DEC with a certain pattern, like for cone searches and things like this. Like just raw searches on RA and DEC would not be optimized in that case. But we will provide examples of that. So working through those ADQL functions, should be efficient. We are also going to layer on top of that some BigQuery's version of indexes for certain ID fields, like for the DIA object ID field. We will have search indexes on that, which should let us have a certain level of optimization on that. And this will be on an ongoing process as the system is in operation and we discover what kind of queries people are using and what's sufficient and what isn't. As far as educating the users, I think that will be probably through the typical way that we use Python notebooks and tutorials. And then, of course, we have the Prompt Products documentation site. And if appropriate, some of the information could go on there, although I'm not sure that that's really where we would put like SQL snippets, but for sure we will have Python notebooks, which show people how to efficiently query the system.
All right, we have time for maybe one last question.
Thank you. So the tables look very much like what's in the data previews. Could you please clarify, and sorry if I missed that, whether there is a lot of overlap in the way the data are presented and they can be queried? Because in that case, also kind of to Chris's point, there is already a lot of tutorials that have been developed.
I probably cannot answer that.
I can take a stab at that, Igor.
Yeah.
The tables, there is indeed a huge amount of overlap for the DIA tables with in the data releases. There's some subtleties in how the association is done. In AP, it's done on the fly as opposed to sort of a single pass for DRP. But I think you'll find most of the column definitions and meanings are the same in the two, so there should be a great deal of overlap. All right, let's thank Jeremy again for that presentation. And we'll swap and I will present an overview.
Thanks, Eric. Bye.
Thank you, Jeremy. Do I need something? Oh, yes. So I just need to share maybe the Zoom. Go whatever is convenient. Sure. I see. Multiple monitors. All right. Thank you. And thanks everyone for your patience. So I'm going to sort of resume the maybe more natural logical flow of the session, which is just a general status of alerts and prompt products. These are the reminders you missed at the beginning. I will skip through them. All right, so we changed the order. Jeremy went first, but now we're going to come back to the top. I'm going to give just a general status of alerts and also speak again about template building. You may have heard that already some in the SAC meeting or early science yesterday, but I'll go in a little more detail. Then Xinfang is going to talk about the performance of the prompt processing system that runs alert production. And then finally, Tatiana is going to speak about our machine learned reliability model. And I suspect we'll have some time for open discussion at the end. All right, so on to alert status. As you know, we started issuing public alerts through the brokers on February 24th of this year. This is the background is the graphic of the dashboard we were watching as the alerts went out. And you can see some celebrations both at the University of Washington in the top right, and then also at the summit. So we are sending the alerts to 7 brokers directly that were selected through a process several years back. And there are also a couple of downstream brokers that receive the data through one of the initial 7. If you're interested in what these brokers are doing with the Rubin data they're receiving, I encourage you to attend the broker session tomorrow where they're all presenting. But I think the headline here is that everyone is receiving data and publishing it again. And so this is already an active and rich ecosystem. And you can go and poke around on their websites. One of the strengths of the alert model is since these data are public, folks can feel free to develop the tools that their community and science interests drive them towards. And so there's kind of a rich range of broker services that come out of existing surveys like ZTF, but have been adapted to the Rubin use case. And so they have classifiers and filters and alerting systems and sky viewers and lots of details, which again, you'll see tomorrow on Wednesday. And science is happening. There have been more than 1,000 transients reported to TNS. I pulled, these are from a couple of months back, but folks are writing circulars and presumably papers as well. So the alerts are driving real-time science exactly how we want them to. The documentation site is good to remind folks of, prompt-products.lsst.ao, which has some pointers to the observation status, a little summary of the different data products you get from alerts, tutorials, information about citation, all the usual stuff. So we try to keep this up to date and encourage you to check that out if you have initial questions. I wanted to highlight, because I don't think we've actually advertised this very strongly, but there is now a new service in the portal, the Rubin Science Platform portal, which is an alert viewer. So you go to the alert viewer tab. It's a little hard to see in the small sort of text. I rendered this, but there's an alert viewer tab. You click on it, and you can enter, it's the DIA source ID, which is what actually triggers the alert. And it will pull up the alert packet that generated that alert. So it has the cutouts, it has a tabular representation, both of the DIA object record, as well as the light curve, the DIA source history, which you can plot. Right now, it's not distinguishing between the different bands, but I hope that we'll be able to support that in the future. And certainly you can filter and use the usual Firefly tools to modify that plot in the web browser if it's convenient. Driving that GUI service is an API, a service called Herald, which if you can get a token from the RSP, you can, in a Python notebook, query that service and retrieve the alert packet either as transmitted Avro or in several other formats, or if you just want the cutouts or the schema. And so this provides an interface to these data. Again, the thing about alerts is that they are world public. The contents are world public. So while you have to have data rights to use these RSP services, you can freely take the contents and run away and do the science you want with them and share them freely. So just want to distinguish that sort of subtlety. The alerts are paced mainly right now by template availability. And so our next steps are to try to expand those templates. And I'll talk about that in some more detail. We want to continue improving the reliability model, which Tatiana will discuss. We see some evidence, which this figure shows here, that we would gain some incompleteness with some light deblending in the difference images. Rubin depths. There are variable and moving objects that appear next to each other. So Ian Sullivan is going to talk about the work he's done there during the Science Pipelines talk on Thursday, as well as the crowded field session. So I'll point you to that. We have promised and have not yet implemented both upper limits and precovery force photometry. Those are important if you're interested in young transients. So that's another priority for our development over the next months. And of course, we need to scale up and really give the sort of firm performance numbers for completeness and purity and so on, as well as respond to bug reports and questions from users, which are super helpful for us because we can't look at hundreds of thousands of alerts per night, and it never fails that when somebody is doing a science-driven investigation, they drill into a corner of the data that we're not looking at and find something helpful. So please do give us feedback. All right, talking about templates, as I think you probably have heard several times already, we have deployed templates from commissioning and from DP2. You can see the map both on this slide and with the interactive viewer at ls.st/template coverage. It's not that much area. It's only a little north of 1,000 square degrees in I and Z and less in other bands. That's driven just by where we were appointed and some of the depth in DP2. This is a little less than the total differenced area in DP2. We sort of trimmed off some of the rattier edges, which I see people already finding as they explore DP2 themselves this week. But that's the area we felt like we wanted to put into alert production. So what do we need to do to enhance that, increase that? We have a couple of technical constraints that sort of limit what we can limit. They shape our approach to template building. The first is, as you heard in the first talk, there's a database built on Cassandra that we call the APDB, Alert Production Database, that is kind of the brain of and the memory of AP. So as we take and process new images, we're always writing history into the APDB. We're querying history out to put in the alert packets. And so we need that to be performant at full Rubin scale. And as you increase the false positive rate, we increase the load on APDB. And there is a limit that we have skirted at times during first alerts in particular when we were at a very, very high alert rate. So we sort of know where the boundary is. But that sort of informs what we're willing to put into production because we need to control that false positive rate. So we're always making optimizations, trying to tune and improve the pipelines, but bad templates are a significant source of false positives, and so we want to be cautious. The other issue is that we both can't and don't want to change templates frequently. Empirically, it takes us a while to generate new ones and vet them and put them in production. It's not a turnkey, update by tomorrow sort of process. So we want to put a template in that we can leave in for 6 months or a year, and so that both increases the stability and interpretability of the light curves that results, and also is sort of operationally more possible. So with all that, all that is to say that as we're thinking about templates, one of the things we worry about is gaps. The fill factor of the camera is about 88% when you project it into the tracked in patch space. And so, if you just put a single image in as a template, you would lose 12% of the sky to chip gaps. So we need to dither that out. If the dithers are random, it only takes 2 or 3 images to get rid of most of those gaps, as long as the input images are themselves template quality. So we do have to pay attention to, not every image is a template quality image. So what we're doing right now is, we have done these initial deployments from kind of data releases, so DP2 being a canonical example. And what we're trying to get spun up now is, the incremental template process, which is still kind of a batch processing system, but rather than in a data release, we're processing a huge chunk of the sky all at once, and we can't really afford to do that all the time, all the sky. So we have to sort of pick and choose. So the idea is we take a history of where we've pointed, projected into maps on the sky, count up how many exposures are in each heel pixel, and then ask, which tracks are good candidates for co-addition. And then we run the pipelines, make the coad, examine the coad in metrics and visually, And then, if it's good, then we're gonna put it in production. And so we've just about closed that loop. This is an example of sort of why we want to look at the templates and examine them before we put them in production. This is a spatial pattern of the alerts on the sky from a section of the DP2 templates that we deployed. That this didn't come up with the metrics and inspection we had done, but you can see visually, especially maybe over here. Apologies, I didn't make a better zoom in, but there's a clear grid pattern in the data. And you're also going to find this in DP2 because these are DP2 templates. This is coming from basically sharp discontinuities in the PSF printing through into the template COAD in the chip gaps. So if you have a really poor seeing image in the background and better ones in the front, then it's really going to struggle to sort of handle that abrupt jump. And so we do have metrics now that allow us to try to identify this ahead of time. But in this case, we missed it, and it is in production now. So these are the sorts of things we're learning as we go. So as described, these are the maps that we're using to think about which areas to build templates in. I'll just walk you through these one by one. So the color scale here, blue is like a single image, red is 10 images or more, and white is kind of in the middle. And then you're going to see some green areas where you sort of have more than 3 images in every patch, and those are places we would look to start to do templates. This is the U band. So you see there is really not very much coverage there. That is, with all of the Rubin data taken and on disk to date, there's not much more we can do in U band. There's just not much available. This is G. Likewise, not a lot of area available for us with what's been taken. This is R coming next, a little more. I has quite a bit, and sometimes you hear a little bit about some of the AOS stability testing. So these are some dense regions that, if they're well enough dithered, and that's something that I want us to investigate, should be a good source of templates. So that's I. Z has the largest area available to us, although unfortunately we're coming now in early fall into kind of this region, and so we're not as rich in taken data for immediately usable templates, but that's just the fact of life. And then this is Y, where again we don't have a huge amount of coverage. So to the question of what's available now, that's kind of the hint, and putting some numbers on it. The largest area we could deploy if optimistically all of those regions were usable is in Z band, and that would get us maybe to a little less than 8,000 square degrees. So we're going to go ahead and do this. We're going to try to get this done sort of in the downtime period over the next little while. So then we come back on Sky, we have as much available as we can, but it's not really an overwhelming quantity of data. So that motivates us also to return to an idea that we've kicked around, which is the idea of considering DECAM templates. So there is on disk already at the USDF a large quantity of DECAM data that was used for some offline TOO processing, and it excludes the galactic plane. There is, of course, plenty of DECAM imaging of the galactic plane we could examine if we get the high latitude stuff right. So we're going to come back to this idea, especially motivated by the IR1 LIGO campaign that's coming later this fall. The biggest challenge is false positive rate. There's obvious limitations just from the changing the instrument, and pipelines and stellar proper motions are all going to sort of provide us a floor. We also see, frankly, quite a great deal of correlated noise driving false detections. And so in our head-to-head comparisons of subtracting Rubin minus Rubin and Rubin minus DECAM, we see as high as 10 to 30% more false positives, 30 times. So it really is quite extreme. I think given the downtime we're facing right now, it motivates us to come back to this and work a little harder and see if there are mitigations we could put in place that would allow us to deploy this, because I don't see us getting significant sky coverage otherwise. But it's going to be hard. It's going to challenge real bogus. So we're looking at it. We're thinking about it. But you know, I wish I had a better story to tell you because it's very appealing, but it's technically hard. All right, this is just a reminder of the release schedule. Jeremy already mentioned the September, October for the PPDB, and then later this calendar year for the visit images, the prompt visit images. So look forward to that. And so we're going to scale up alert volume and quantity over the next year as we are able. And finally, I'll just direct you again, as always, to community with comments and questions. We do read them, think about them, and hopefully come back and write the answers once we figure it out. But that's sometimes that loop takes a day or two. So thanks very much. I'm happy to take questions. Okay, why don't you go with the question online while we feed a microphone? You want to?
So Michael Woodvasey comments online about the alert viewer. Wait, you're right here. Never mind.
All right.
You can read his comment.
There's a question
on
here.
Slack.
If he changes his mind, he can ask it in person.
Yeah, my question is if there's a region where you have enough images to build a good template, but it turns out the images, the quality is not good enough, you know, poor PSF or clouds or something, does that get fed back into the scheduler?
My understanding, I don't think, is Lynn online?
Yeah, I am.
Do you, yeah, how does the scheduler treat, you know, poor quality images as it thinks about history?
Well, okay, so actually I heard a slightly different, okay, so there's two questions here. One is, does the scheduler know that, and I'll say specifically the FBS because anyway, but does the FBS know that we already have templates available in a particular part of the sky and it doesn't try to acquire templates in that part of the sky? Yes, that's a thing we'll be doing when we go back on Sky. Does it know that the template that we already acquired and said was fine to be deployed was actually bad? No, because once we've said we've deployed it, I don't care anymore. That's Eric's decision, right? So if it's been deployed, we'll say, great, we've got a template in this part of the sky. As far as acquiring visits for when we in parts of the sky where we don't have a template yet, and we have this mode in the survey, which is trying to acquire visits specifically to get the inputs to be able to build a template, we do look at the image quality there. We don't have real-time feedback on like whether it was a good image or not, but we're working with the summit so that we can update on a daily basis so we can know what was the actual image quality measured in this image when we build up our information day by day. That said, we only get the information on a whole visit level, and so that's a little bit different than what actually ends up happening by the time you really build the template. So it is still a bit of an approximation, but yeah, we get some of that information.
Thank you, Lynn. Gautam.
Eric, thank you for the update. The PSF discontinuities you showed from Bruno, this is one of the reasons Desk, of course, wanted cell-based coads, right?
Yeah.
And I was wondering what the difference is between the template coads and the cell-based coads, and if something like cell-based DIA would be possible, it would let you do more difference imaging already because you don't have to build templates over the full focal plane as much.
Yes, that is an excellent suggestion. It's one we have contemplated. It didn't obviously make DP2. My understanding, and maybe Ian or other pipelines folks will correct me if I'm mistaken, even with the cell-based coads right now, those are being stitched together into the larger tracks and patches in the sort of usual way. So I think that we can use them in a fairly drop-in manner for the templates without too much trouble. I think that that the template discontinuity issues, unless you go to doing DIA on the cells themselves, it doesn't get around that issue. I think it's something we can certainly think about for DR1. It's obviously not an AP. It's not coming to AP in the immediate future, but yes, it is on our mind, and thanks for the suggestion. Francisco in the back. Anya, so I'll point out that Gregory is sitting in the back there, and you can ask him the RSP question after the session.
So it's a question about templates. So if I have a template with a certain ID, can I reconstruct how the template was built exactly? So if I later want to do a model comparison, for example, I will want to be able to reproduce exactly how this was made.
Yes, we do store the information about what went into the template. You'll need, I think, to really be able to use that, we'll have to wait until the PPIs and so on are accessible later this year. But yes, that provenance information is available. And you know, I don't think we have tutorials for it yet, but yes, you'll be able to get it.
I have an actual question online.
Great.
This one from Meg Schwam asking about whether the shutter motion profiles are taken into account, and if not, when.
Yeah, great question. Thank you, Meg. No, we have not yet implemented the shutter motion travel time. It just needs some attention. That's been hard to come by. We have what's needed, and it's just a matter of finding the person who's going to actually commit the code. So I hope we can get it done this calendar year. I think it's just a matter of attention. Yeah.
Hi, thanks for the update. I just wanted to ask about templates in the Galaxy. Is the current lack of templates due to lack of visits or problems with processing or something else? Thanks.
I would say it's mostly lack of visits. The deep coads that you see in DP2 did run through the Galaxy. The templates that we made from DP2 were slightly more restrictive in their inputs. And so I think we were kind of just on the hairy edge of making a lot of templates there. There were a couple that popped up, and we elected not to deploy them initially because we wanted to start with less challenging fields. But you know, speaking on my personal science, I am extremely eager to get difference imaging and alerts out of the galactic plane fields. So rest assured, we haven't forgotten, and we'll get them in as soon as we feel comfortable. Shreya.
Hi, this is Shreya Anand. So my question was about, you mentioned that incremental template deployment takes about 1 month.
Yeah.
Is that referring to deploying deeper templates in a region that already has good template coverage, or new templates?
I'm speaking there of new templates. We're not at this moment contemplating replacing templates. That will happen eventually, certainly at the data release boundaries. You know, we're going to, after DR1, we're going to do a wholesale jump. It's super disruptive, as you know, to change templates because all your light curve baseline shift and what's included and not changes. So we're trying to minimize that. You know, if there was a really egregious case, we would maybe consider it. But yeah, the month time scale is a combination of, at this point, of you know, wall clock processing time, you know, vetting, you know, doing the discussion, copying. I hope we can bring that down somewhat as we get up to speed and do this at scale. But it's never, I don't think it's ever going to be an immediate sort of thing. Let's take Igor, and then let's move to the next speaker.
I'm personally very aware of how complicated things get when it gets to target of opportunity observations, where you don't have templates or good templates. I know how hard you and the team are working to do image subtraction and detection anyway. Could you please let us know what's the latest in terms of distribution of the information you managed to get in whatever way, and what are the, in your opinion, the feasible plans in view of the LIGO and Virgo IR1?
Yeah, so I'm super aware that when you take TOO data, the whole point is to get the alert, get information out sufficiently quickly that people can do follow-up. You know, these are time-critical events, and We haven't achieved that in our TO campaigns to date, and I think that's a deficiency. My view is the more we can put through the alerts machinery, the better, because that is not manual, it's automated, and it goes to the brokers, and it's immediately public, and it is the very best we can do. And so I think that's a large part of the motivation for coming back and looking harder at the DECAM templates with a view to IR1. I think there are ideas for how we could do dissemination, from a more manual process, but I think it's always going to be a little bit of a compromise. Gautam, let's defer this. I want to go to the next speaker. If there's time at the end, we can come back to it. All right. That's all for me. Let's go to Xinfeng.
Well, Xinfeng is coming up. I will just advertise that a few of us will be talking about DCAM processing in the coffee break after this session. And come find me if you would like to talk about processing the DCAM images with the Rubin pipeline.
Can people hear me okay? Thank you. That's different now. I wasn't sure because so I'll spend a few minutes to kind of tell you the production side of the story on behalf of the whole processing team, which is actually a small team with a name. So here, many of us are here today or online, so we'll take questions or discussions. Good. Thank you. Okay, so just a quick kind of introduction of how the system works. So what's producing these products is a processing system, what we call the prompt processing system, that would do automatic real-time processing whenever the science data come. The system we rely on is for the summit to send us an advance notice before they take the actual observations. So before they take an image, they will tell us in the message, that's what we call the next visit message, to tell us where in the sky they are going to take the exposure, what filter, so we could prepare ahead. Here at the Slack's USDF, prepare the worker to so when the image is actually taken and transferred to Slack, then we could start processing as soon as possible. So as you have known, that so the prompt processing actually has been working even in the precursor, the LSS, lattice data, then ComCam, and when the LSSC come on Sky, we started to process LSS data as soon as possible, and actually we think like the LSSC came on Sky last April, within 10 days, we actually started to produce alerts based on some early templates that was like not for science, but for the system to do our testing. And meanwhile, as we accumulate more visits and have good templates, we started to update the templates. And in February, we started our first alert, the public alerts that's sent out to the community. And from now on, what all the plots I'm showing you is starting with February 24th, the first day we get our public alerts out, and all the way to July that we last had observations. And I only count the FPS LSST survey. That's the kind of data we intend to process by the prompt processing. And I skip all the nights that have no observations, maybe because it's all engineering data, or maybe because the weather was bad, or whatever reason. So all the plots you see will be scaled like that. And this gray bar here are the raw exposures we receive for each night. So you could see that for some nights we got more data, for some other nights we get less data. And the colorful bars are those images the prompt processing system missed. So the more gray you see there, the better. That's all the successful processing the system did. And occasionally you might see events here and there. There's a network outage that day, so we were not able to receive the images here. So that we missed a lot of images to process. And another day, the orange here was due to our embargo storage problems, and then we also missed a little more images. So except those big events, we mostly could process more than 97% of the images that's every night. And if you kind of stare a little more, you see that there are some smaller bar there, the colorful bar. If I zoom those are typically 1, 2, 3% of those images that were missed for reasons we actually know. These green and blue were those that the information from next visit's messages do not match the actual images taken, so we could not process them successfully. But those are pretty small percentage, and we actually understand every single image, what happened to them, why they fell, and we are within the team, we talk about how to mitigate those and how to make these more robust. So overall, during these few months, we missed about 3% in real time, and those will be done in catch-up processing the next morning when we are in full operations. And over those 3%, kind of the 4 major reasons of the failures were from the network outage, that's the red here, embargo storage problems, or the orange, and the blue and the green were from the next visit events not matching the actual exposure. So we understand what happened. We are working on how to not let that happen. And so far, if there are templates available for the image, then we do the full alert production pipelines and then generate the alerts. If not, we do just the single frame only processing. But once they have templates, we'll just do the whole processing. And here are the counts of the alerts starting when we started the public alerts. So you could see the peak back in February when we do the public alerts. At the time, we try to just have more alerts at the time. After some fields, we had templates. And after that, we have some quieter time, mostly because we were observing places that do not have the templates. And in May, we deployed the DP2 templates, and then you started to see the alert count starting to bump back up. And there are many factors why we might or might not get alerts. So templates is one of those, and also is what observations are being done. And when the SCT survey started, then we started also get more FPS observations, and then we got more alerts as well. Here I'm showing you the latency of the alerts, which is like after the shutter close, how fast we could get the alerts out. See, most of them kind of lie around a little bit more than 2 minutes. And if you read carefully, the mean here is about 140 and the 50% median is 136. So that's kind of where we are right now. And sometimes we get some outliers like spread to a higher latency. Mostly it's due to some events, such as if the storage are not performing that well that night, then they tend to map to some longer latency for that night. When we had the network outage, it's actually not so bad. Or there's another night that we have the Kubernetes infrastructure issues, and then we also have a lot more outliers that's much higher in latency. And we could also break down what's taking. So for our pipeline, we actually track the timing spent on each task. And here just showing you that from different tasks, they are taking different amount of time. And the team is working hard to optimize this as well. Like if you see the blue line here, that's the compute reliability. There's a drop there. The team has found out that how to actually kind of an issue there in the pipeline, and we'll fix that, and then that significantly drop the time. So going forward, we will continue to optimize better to improve the speed, also improve the reliability. Hopefully, as many images get processed in real time as possible. And if you are interested in real time what's happening, we have a dashboard, SST alert stream status that you could monitor in real time, what's happening at that night. So that's all I have.
Thank you, Xingfang. Questions? This is the hard work that it takes to bring real-time alerts to you. So here's one.
I guess I'm trying to get a sense of just how often these failure modes are happening right now with 800,000 some odd alerts per night, and how this scales when you get to full LSST alert rate. Have you folks done testing with the anticipated alert stream rate of 10 million alerts a night and seeing if there are different failure modes that bottleneck you, or if there are other things that degrade?
We kind of scaling test kind of the thing. Yeah, so before the operation time, we have done many, actually 5 operation rehearsals and try to just do the full speed. And we identify actually a lot of issues back in operation rehearsals. And actually the operations with the real data have been very smooth so far, finger crossed. But mostly because we solved a lot of the blockers back in operation rehearsals.
Size your pie chart of the failure modes, 90+% are independent of the alert rate. They're external to the system. So, other questions?
Thank you so much. Katarzyna Kruszyńska. I have a question about the unprocessable images, because they Anyways, were they unprocessable due to the 4 reasons that you showed in the pie chart, or was it something else?
Yeah, the unprocessable was what I call the MD mismatch, the metadata mismatch, because we rely on these advanced notice that we call next visits, and if what it says the sky rotation angle is different from it actually is, then we preloaded the wrong data to do the processing. So right now we just drop them, but we have at least 2 plans right now. One is work with the Summit team, so they try to be more accurate in what they send us about the next visit messages. Another is maybe we just take the time to preload. We might just, you'll be longer in terms of latency for those visits, but at least we still get them out in real time. So that's the two plans we have right now.
I'm Baden Erb. I'm on the DevOps team at Rubin, and I can speak a little bit for the big, scary red LHN outage. We're currently working with our internet service provider who runs the fiber from the summit to La Serena, and we're looking to have better reliability when it comes to the specific fiber hardware, because that was a big part of some of our LHN failures was the actual fiber line from the summit to La Serena. And we're working with our contractor to have better quality. So hopefully we'll see that go way down to 0.
Thank you for working on that. Yeah, another thing is like, so once the network is out, just one night could make a big wedge there, because we are talking about really, really high reliability here. So 2 hours without network could mean 1-2% easily.
All right, last question, and then we'll go to Tatiana.
Thank you. What are the main bottlenecks to reduce the latency?
So yeah, I guess the team had considered multiple fronts. Of course, there's the part on the science pipeline always try to optimize and to make things run faster, and also well, I guess this delay in image arrival. Hopefully that could be reduced, and also the storage performance that sometimes drag the latency high. Hopefully the storage could improve. So there's like almost every factor. We are looking into every factor possible to shrink that.
Xinfeng, one more time.
There's a question online while transitioning, if that's okay.
How about we take it on? Well, let's reply online.
Answer offline.
Okay.
Next speaker is Tatiana Sarah-Cuellar, who's going to speak about the reliability scoring we do in alert production.
Can I use this? Oh, okay. So I'm going to talk about the real bogus, and since I have 20 minutes, I'm going to talk about everything. So just to remind everybody a little bit, so every DI source detected on the difference image is going to have a reliability score, which ideally values closer to 1 indicate a real astrophysical object, and values closer to 0 indicate a bogus or an artifact. So for Rubin, that score is assigned by applying a machine learning model that in this case is a very light convolutional neural network that takes as input the difference, template, and science images. And the output is this value between 0 and 1. And it's very light because we need to keep the 60-second mark and all of that. So this past year, we introduced several things. The first one that I want to talk about, it's about the reliability version. So the model used for DP1 and also for DP2 is the version 0.1. And this year, we introduced the 0.2 and the 0.3. The 0.2 was used for the initial alerts until July, until the beginning of July. And then the 0.3 is the one currently being used for the alerts. And also the reliability version is now part of the DIA source table. So everybody can know which model was used. So this is a small summary of the models that we have so far and which data was used to train the models. So the base model was trained using DC2 and fakes data. And then from there, we fine-tune using COM-CAM fakes to create the 0.1 version. And then from the 0.1, we fine-tune to create the 0.2 using LSST-CAM data with Suniverse labels that I will talk about that in a moment. And again, from 0.2, we fine-tune to create the 0.3 that use both the LSST-CAM data with Suniverse labels and the COM-CAM fakes. So the LSST-CAM data with Suniverse labels, we launched a citizen science project on the Suniverse platform that is called Rubin Difference Detective, where we provide the volunteers the template, the science, and the difference image, and we ask them, please label whatever you see on the difference image as real or as bogus. And the analysis of these classifications is what we use to create the LSST-CAM data with Suniverse labels. So the project was initially released with a little bit more of 200,000 unique DIA sources. And the way that we select the sources was by cross-matching the DIA source catalog with TNS, the solar system, the Gaia. And we also filter based on the real bogus score available at the moment, and also with some morphological features, in this case, the extendedness. So this is just general statistics of the project. We reached a little bit more than 1 million classifications. And the other plot is just showing the general distribution of how many times the people click real or bogus for the specific data set. So if we group by each individual DIA source, each one has between 2 and 16 classifications. And in general, just by consensus, the people agreed in the majority of the time about one label or the other. But with citizen science project, we need to be a little bit careful because this is, I mean, for many people, it's the first time that they are doing any scientific specific task. So to illustrate a little bit the idea behind that, I have this plot where the horizontal axis, where each dot is a unique user. The horizontal axis is the total classification, and the vertical is a metric that we use to measure how reliable the user's classification are. And the color indicates the ratio of the number of times they click real over the total classification. And in green, I'm showing just for reference how the Rubin team is in that plot. So that includes me, Eric, Federica, so just to reference. So you will think, or at least I will think, that the more classifications a user make, the better it's going to be. So ideally, the user will converge to have the expected ratio between real and bogus, and also to have like reliable classifications. So something like just like a straight line, but that's not happening. So we have some users at the end in blue that have like a lot of classifications, but they were like very optimistic and they classify everything as real. And we have other ones that are very pessimistic and classify everything as bogus. So there are many papers where they deal with this issue in different ways. And also the Suniverse team has like suggestions about that. But in this case, we decided to use a probabilistic approach that was introduced in the Space Warps paper in 2016. So the idea is to, instead of just using the consensus and use just the consensus, like what was the majority vote, we update the probability of the source of being real based on each classification. And each classification has a different weight that depend on the user that did the classification. And the way that we weight the user is by measuring how well they did on a reference data set. And the reference data set, it's a data set where, for whatever reason, we have a ground truth label. So for each, so in the paper they use agent to refer, but it's referring to a specific user. So you build like a confusion matrix for each user. That matrix tells you how the user's performance on that specific reference data set. So here I have 4 examples, 2 when the final probability converged to be real and other were converged to be bogus. And this is, sorry. Okay, this is high confidence examples. I'm gonna explain that in a moment. Okay, so after applying all of that, this is the final distribution of the data by each subset. And in the majority of the reals are solar system objects, and the majority of the bogus are detections that has a cross match with the Gaia catalog. And also, like when you saw in this case, like we have each point is a classification. So we separate the stable one from the unstable. So the stable means that the final label was reached within like the last 3 classifications, and the unstable means that only in the last classification the convergence was real, which was reached. And for the training purposes, we are only using the stable case. Okay, so I'm gonna talk a bit about the performance of the current model for the alerts, that is the 0.3. So the horizontal axis is the real bogus threshold. The vertical axis is the purity in blue and completeness in orange, yellow. So given the data set, we reach performance requirements. But just to remind everybody that this is like we test the model on the data that we have available, and that may not be fully representative of the on-sky performance. And then this is more specific by each set. So the best ones are the solar system objects, as always. And then there is still some room for improvement for the Gaia, for example, sources. So the other thing that I think it has been around forever, but it's more important to talk about that now, is the real bogus cutoff for the alerts, only for the alerts. So for the current version, the cutoff is at 0.5. So that means that any DIA source with a real bogus score below 0.5 is not making through the alert stream. So we are right now working on having a model that is more confident about the bogus, so that just assign a 0 score to any like obviously clear bogus object, so we can have the cutoff more closer to 0. Yeah. And then all of this information is available on the tech node. And if you want to work with the DP2 data and you want to use the real bogus score, I will recommend that you check the tech node again. And okay, so current work, I mean, of course, there is a problem getting the labels. So this Universe project is right now on pause while we decide what is the best way to proceed. But right now we are collecting labels with recent data with the collaboration of a group of students at UPenn. For sure, the next version is going to use the LSST CAM fakes and not the COMCAM fakes. And we are also going to use other catalogs besides DNS and Gaia. And yeah, that's all.
Questions for Tatiana?
Hey, Tatiana, great talk. I saw that, in the performance that you folks were getting on Zooniverse, it's absolutely the case that there was a lot of scatter, but of course, you folks are in fact doing much better than average with the human classification by experts. And I was wondering if that suggested maybe outsourcing real bogus classifications beyond just UPenn to the science collaborations more broadly, with some kind of dedicated interface at RSP to do that at scale. You know, I suspect DESC and TVS and other groups would be very, very happy to help with this effort if it made everybody's life better.
So we have considered many scenarios. So right now, these students at UPenn, they are using like a very custom and local like label system. And I think it's a little bit complicated to have a Zooniverse project just for a specific set of people. And so it's either or use Zooniverse and make that project public to everybody, or just use a very specific, like very local system to make the labels. So it's a little bit harder to do something in between that.
I think I will just add, we did some labeling internally within the project on ComCam using an RSP type interface, which I developed before Claude was really a thing. And I wish I had that time back. I was surprised it was more important that we didn't do a lot of training, because like, oh, these are scientists, it'll be fine. And there was a lot of label noise. And so I think even with PhD users, the same issue I think holds as for a public Zooniverse project. You got to provide good training. And so I think it's on the table, but we have to think about where to put effort. Let's go to some different, let's go to Fed if she wants to make it.
It's not a question. I just wanted to add that keep in mind that we ran this as the image quality was evolving. And so we're looking at images and there are things that we're solving actively in Rubin, but they look weird, right? And so also you need that continuity of labeling things the same over time as the image quality changes, which introduces additional label noise.
This is pretty specific. Can you go back to one of the one that showed the stamps? But it gets to the question of what we're trying to do. No. For the first, like the table of like 20 stamps. One more.
Okay.
Big, like, yeah, that one. What do you think the correct classification is on that last row?
I'm gonna say that is for sure very close to 0. For the last one.
Right, because you could say, oh, there is a real thing. But I just want to make the point that, like, if the answer is there's a real variable, but too near a thing that we think is an artifact, I think it's totally fine to say, look, we just don't have confidence in it. But I was curious what the philosophy of the team was about that.
So in the, yeah, I think so. So in the, for example, the Zooniverse tutorial, we were, I mean, please base your answer on what you see, I guess. So I mean, you don't, I mean, because of whatever reason, there is nothing like very visible in the middle. I mean, it's supposed, the sources are supposed to be like centered on the image. So this cut off was because something was centered on the difference image. So you don't see anything.
Let's go to Ian and then.
I will just point out, Michael, that is a case of a pipeline failure that I separately fixed last week. So again, things are evolving. Hopefully the users wouldn't get that particular cutout in the future.
Yeah, so there's classification noise and then there's classification bias, and those are two very different things. I'm thinking that, you know, one of the major goals of LSST is to discover the unexpected. And if you're biased against finding the unexpected, you won't find it. So, for example, some of the last time I looked into this, the brokers are very, very finely tuned to discover this kind of thing or that kind of thing. And if you're finely tuned to discover those things, you won't discover something that was unexpected. So I think we have to think more about making examples of that, picking up examples of that and using that as part of the training.
Francisco in the back.
Yeah, thank you for the talk. So my question is whether you are also injecting synthetic objects while you're labeling, because this could be useful to calibrate what the users are doing. I mean, I had to look at a lot of simulated images myself to know what to expect first, but this could be useful. Also, we can talk later.
So we are using injections for training, and actually including the injections. Like models using the injections are way better than only with the real data. And that's the case. I mean, that's why we decided to move from 0.2 to 0.3. Yes. Okay.
Yeah, the Zooniverse raters, as you can see in the 0.2 model, as you saw from that example, even experts can argue about what's happening on faint sources, and that comes through in the scoring. Mario had a question.
Yeah, Tony's comment made me think about this, but I'm coming from the solar system side of things. I'm always worried that we're going to lose the next interstellar comet or the next like weirdly disturbed asteroid or something like that. And I keep thinking that these real bogus classifiers, they should really be classifiers of known bogus things. And if it cannot prove known bogus, it should let it go through, because it could be something interesting scientifically. Where would you say your classifier is kind of in that context? What will it do if it finds something that looks very unusual?
So, I mean, the model knows what is in the data. So if it's something like super new, I mean, probably the score is going to be very low, or 0.5, I don't know.
So you're saying it's trained to recognize known astrophysics, and everything else it thinks it's not real.
I mean, it's trying to recognize, whether something looks like a real astrophysical source or whatever. Okay.
So I'd argue that's dangerous.
Sorry, what?
I would argue that's dangerous, that we might lose interesting objects because of that.
So you're saying maybe binary classification is not what we need to do, but other.
No, I'm arguing that if it's not known what something is, it should be passed on to the users and brokers, right? So like that should be the bias, as opposed to being biased towards, oh, I recognize a star, or recognize an object that I think this is what an astronomy is supposed to look like. Because we might lose interesting objects if we think that something unusual is not real.
So I think if we saw something unusual that is not in the training set, the classifier would kind of default to a 0.5-ish score, right? So, but maybe the studies that you're doing of the latent space can show you that that doesn't live in the latent space in the position of known objects. So I think that's the only way. That would be the only way to rescue an entirely novel presentation that the model has not seen before. And otherwise, if you have ideas of what you could be this novel thing, like if you're saying a comet, and we could like simulate some ways in which the comet.
No, but I'm arguing is that we shouldn't be simulating astrophysics. We should be collecting defects. We should train it to be very, very good at recognizing bogus things. And anything that it cannot identify as something that's bogus looking from actual data, just pass it through.
I think the phase space of possible boguses is much less than the phase space of astrophysical things. So, and I think the classifiers work great on moving objects. All right, last question. Oh, never mind. Okay. Any final questions? All right, sounds like many of us have philosophy to debate over the coffee break, but let's thank Tatiana and all our speakers.